It's the packet thrower! Welcome to the channel! In this video, we're going to kick the tires with netconf, and we're going to use it to grab some information off the router and also do some configuration. Netconf is based on the Yang models and uses SSH to connect. So one of the first things we need to do if we want to be successful with this is we want to download a tool that can help us understand what Yang models are on a Cisco device or another vendor device if we want to play with that. Fortunately, Cisco has made a cool tool called Yang Explorer available on GitHub, and we're just going to go ahead and download this, and I'm going to set this up on my Ubuntu server. So my Ubuntu server, I'm just going to go git clone and paste in that address, and then we're going to go into that directory. Inside here, we got two things that we really care about. We have the setup, which is going to set up the modules that we need and also the database. And then the start is going to actually start the process so that we can access it. So first I'm just going to go ahead and do the setup. And this is going to take a little bit to run. So I'm just going to pause this and we'll pick it up when it's done. The next thing we need to do is just edit our configuration a little bit. So if we look at the start.sh, it's going to start running with a local host binding, which means that we can't access it from my main computer. So I'm going to go ahead and change this to be the DNS name, which is ubserver31testlab.com. And then it's also going to run on port 8088. So if you have a firewall running on your server, you may need to permit this. That out of the way, I'm just going to go ahead and start this. And I should be able to go to this URL. So this is the Yang Explorer in all its glory. You might get prompted to run Flasher depending on your browser and your settings, because it does use Flash elements. The first thing we want to do is we're going to go ahead and go admin. And we're going to sign in with admin. And inside here, we're going to go ahead and create a device profile. And this profile is going to be CSR31. It is going to be a CSR. We could also do Nexus, Junos for Juniper, or the XR routers. And apparently I've done this before, so I'm just going to go ahead and enter in the IP address for this. It's going to be 830 for netconf. And I'm actually going to create a new user here. I'm just going to call it netconf, and then password is going to be netconf. Actually, and the password is just going to be meowcat123. We can also do a restconf, which is also a Yang model but uses HTTPS, but I'll save that for another video. So I'm just going to go ahead and save this. Oh, I need to give a description, so I'm just going to say CSR31 router. So now that's done, I'm going to go back to the main URL. And you can see I'm already signed in from admin because I already went to the admin console. And right now we don't have a lot going on, but if we click, we can select a profile. And before we get too carried away, I got to go over to our router here. And we actually need to enable netconf, so we can do that just by typing netconf yang. And then there's a few options that we can tweak, but all in all, we can just hit enter here. And then if I go show netconf yang, I can do status. And we can see that it's enabled. It's using port 830, like we said. And we'll be looking at this option in more detail later, but this is how it allows for configuration rollbacks. So inside here, I should be able to click on capabilities. And I actually forgot to create this username, because you can tell I very clearly plan these videos out, and I definitely don't do a lot of them on the fly. So I'm just going to say netconf, privilege 15, secret, and then meowcat123. So now, if I type capabilities, we get a response back that we're talking in netconf. So it's great we have communication, but we don't have any models yet to play with. So we click on Manage Models, and then we can select our device profile. What this is going to do is query the router and see all the models that are available. They're a fair amount here, but for our purposes, what I'm going to do is just go ahead and select all of them and click on Sync. So that went ahead and downloaded a bunch of models from my CSR router into our Yang Explorer. So we can check that out by going to Workspace, and we can see all of them here. I didn't quite end up downloading all of them at the end of the day there because some of the nested dependencies, but we have enough to make a video. So what we'll do is we'll select all, and then if we want to make them usable, we can subscribe. And if we want to remove them from view, we can always select them and go unsubscribe. If you don't want to sync from a device, you can also download these from GitHub. So if I go over to here, this is the GitHub page for all the Yang models, and we can see we can go vendor, and we have Cisco, Juniper, Huawei, and such. So we can go Cisco. We have Nexus, iOS XE, and iOS XR for service provider stuff. So if we go XE, and then it is sorted by the firmware version. So the latest version is 1721. And we have all the models here that we can look at or download. So what I'll do is I will grab this, and I am going to open up GitHub Desktop, and we're going to clone the repository. Currently I already have that, so I'm just going to call that 2. And then once that's done, I can go ahead and manually add a Yang file by going Add, Browse, and I don't really care which one we're doing for this example, so I'll just click on one of them, and then I can choose to import. Anyway, with that out of the way, we can go back to our Build tab. With that out of the way, we can go back to our Build tab, and we can see here that we have all the options that we can play with. If we know where we're going, we can drill down. So for example, if I was to find iOS native and start expanding this, we can find things such as hostname, or I can search here to make it easier. I can just type in hostname, and it is going to show me where everything that has hostname is, and I can just double click it. And that will bring me to exactly where it is in the structure if I can't find it. So now we can actually start working with this. So if I wanted to grab the hostname value, I can click on this and I can choose get. Now once I do that, I have to generate the remote procedure call, or the RPC, so I'll click on that. And that is going to format the XML in a way that's going to request the hostname. And that is going to be a get operation. So if I'm happy with that, I can click run. And we can see that the host name for the router is CSR31. If I look on the right hand side, I can see some properties about that particular if I look on the right hand side, I can see all the properties where that field has. So I can see things like the name is host name, I can see it's read writable, it gives me where it is in the path and the description of what it does, and also the XPath filter, which we'll be talking about when we get more to the command line stuff. So if I want to change that, I can just click down here where it says config, and instead I can type in a value. So I'm just going to call this meowcat r01, and we'll build our RPC. So we can see this time it is an edit config operation. We are targeting the running. I'll show you what that means in a minute. And we are pushing the host name meowcat r01. So if I run this and we go back to my router here, we can see that the netconf user has logged in and the host name is meowcat r01. If I go back over here and decide that I want it to be test lab, I can build the RPC and go run. And we can see that if I hit enter, it is changed, and And we can see that we had some configuration done by netconf or restconf. We didn't see it the first time there because I had to clear the screen because I had a bunch of other lab stuff on there. Changing the host name's a pretty easy example, so let's have a look at a more complex one. What we're going to do is we're going to create an interface. So we'll scroll down until we see interface, or I can search for it. And we have a list of all the interfaces that are supported by the model. And so I'm going to do a loopback. So set this to configuration. And the name I'm going to say is 66. Description will say configured by netconf. And then if we want to have an IP address, which is always helpful, we go to IP. And this isn't quite the structure that you might expect, but we have to go to address choice, and then address, and address choice, fixed because we're doing static IP, and then primary. The reason why it's like this instead of just IP address there is it's the Yang attempt to structure the data in a way that's more standardized. So we can go here and enter in an IP address. And we need a subnet mask. So I'm just going to say /24. So if we're happy with that, we can go ahead and build the RPC. And this is, again, a more complex one because we have more options, and you can see that the tool has built the request for us. So if I run this, we get an OK in response, and if we look, we should have a new interface. So I do show run loopback 66. We can see that is the way it's supposed to be. What you can also do is you can build a request, and then you can check this box if you want to manually customize it. So instead, I want to do 67. And then this is going to be loopback 67. So we can manually customize this without having to build it here. So if I run this, we got another OK. And we can see loopback 67 is up. If I scroll up, yeah, there's that loopback 66 I did earlier. We'll just check the configuration. So that's how you use the tool to learn how to use the models there. You can see that each one of these fields tells us where it is. Sometimes they offer descriptions, they give us a path, and they give us an idea of how to actually work with the particular fields. All in all, this gives us a nice way to work with the model there so that we can understand what we're doing when we're building our scripts. If I want to, I can click on Python. And this is going, just like with Postman, this is going to spit out a sample code that we can use. So if I copy this, it isn't a perfect script, but it gives us enough of a skeleton to work on for getting what we want through Python. So what we'll do next is have a look at a really cool netconf feature, and that is the candidate data store. What this does is stores the configuration until we commit it, and this is going to allow Cisco to have a commit-based confirmation, kind of like what you have with Juniper for their CLI. So let's go ahead and turn this on. And it's going to go ahead and restart the Yang process. And you can see it's transitioning from running to candidate. Okay, so that's ready to go. So now the first thing what's going to happen is if I clear this, so that's done. If I go ahead and try and change something, like say test lab R11, and build that RPC. If I try and run this, it's going to give an error because it's trying to run on the wrong data store. So I can fix that by going to operations and then changing this to candidate. So now we see the target before it was running, if you noticed, and now it is candidate. So now if I run this, nothing happens on our device. And the reason why is we need to commit this when we're happy with it. So if I go up here and search for commit, we have a few options here. We have commit confirmed with a timeout, or we can just do a standard commit. So first, if we just want to do a standard one, we can just click this and go build our RPC. And then we will run it. And we should get an OK message. And if I look here, our change has happened. So let's play with the commit confirmed a bit. And then we'll push that again. So we'll say run. And then I'm going to reset it so I don't confuse myself and go back down to the commit section. And this time we want commit confirmed. This is going to be an operation. So we're going to say that this is on. Empty is perfectly fine for the data type here. We can see it's empty. Then for the timeout value, we can go ahead and enter in a number. So I'm going to say 30 seconds. And then we need to set a persistence ID. And what this does is allows the netconf to commit the session after the SSH is terminated. So this is always a good practice. So I'm just going to type in anything. I'll say 1111. And we can build the RPC. So that looks pretty straightforward. So we'll go ahead and hit run. And if we look at a router, it should be back to CSR 31. And if we wait about 30 seconds, we should see that it reverts back to the way it was. So we see that is reverted because I did not commit it. And we're back to the test lab 11 that I randomly put in. So if we did want that to count, we can go ahead and set that back to what it's supposed to be, CSR 31. And then that is going to the candidate datastore. And we'll push that. And we will wipe this out. Go back down here, set operation. And we will do commit confirmed. The timeout will say we'll give ourselves 60 seconds just in case I get distracted. And this time we'll say 2222. So we'll go ahead and push that. So now we have our change and we have 60 seconds to actually do a commit. So we can do that just by resetting all this and going here to commit. If we're happy with that, we just run it. And we see we got an error message because it doesn't have a persistent. And we see there's an error message because we don't have that persist ID. So we'll go back down here and I said it was 2222. We'll go ahead and build that RPC and we'll commit it. This time we get an OK. And now this won't revert back to the way it was. There's a few other things I want to show you before we end this. So we're going to go over to my Red Hat box. And the first one is a handy command line utility called netconf-console. And this is a simple CLI utility that we can query netconf with. So I can go host csr31 testlab.com. Port is 830. The user is netconf. The password is meowcat123. And then we can pick our operation. So I'm just going to say get. And we can then tell it the XPath filter. We can get the XPath by going back to here. And then on each element I click, there's always the XPath filter where it tells us exactly where it is there. So let's find something worth looking at. How about NTP? So we can see that it is native NTP. So if I go back here and say / native NTP, we get all the NTP that's set up on that router. If I want to change the operation, and say get config, we don't get too much difference there, but we also get our answer. Now, if I actually wanted to push config with this method, or the easiest way to do that is to, if we actually wanted to change this, what we could do is do a get config. And have a look at the response. And what I want to do is copy everything in the native here. Then I go here and I make a XML file. I was going to call this NTP. And we'll change this to be 5.5 and 6.6. And this to be 11.11. So once that's in there, we'll go ahead and save that file. Now if we scroll back up, what we want to do is first we need to tell it to use the candidate database. So we'll say db candidate. And then we tell it we want to edit config and tell it the NTP file. So we get our OK message, but remember, nothing is going to happen until we actually set a commit, which we can do just by going up here and then just saying commit. So now if we look at our router, you see we are configured for netconf. And if we look at my NTP, we can see that we added the configuration. If I wanted to, I could edit the NTP file and change the operation to replace there so it replaces the other values. So let's have a look at that. So we will edit this. We'll change these to some other value. Then the operation will be replace. So we're just going to go ahead and do our edit config again, and we'll just go ahead and say commit right away. If we look at our CSR router in VMware, we can see that I've lost all my configuration except for the NTP there. So this is just a word to the wise there. If you're doing a replace operation, there is no partial replacing. You're basically replacing the entire configuration. But netconf does have safety mechanisms. So we can see that it has automatically rolled back even though we did a commit. So it does try and save you from accidental issues there, though you might still be yelled at for causing an outage. Next thing I just want to quickly show you is if you don't want to use the Yang Explorer, you can also use the command line. So if I just go ahead and clone a Yang repository, this is the Openconfig repository, and their goal is to try and make standardization between all the network vendors. If we have a look at this, and let's have a look at the interfaces. Release models, interfaces. We can use the Pyang tool to have a look at that model. So we can say that we want a tree format, and we want the tree depth to say 5, and then we can paste in our name there. Apparently I don't have Pyang installed, so just bear with me 1 second. There we go. And this basically just gives us in text format what the Yang Explorer gave us in the GUI there. So we can see exactly what the string types are expecting. For example, if it's loopback mode, this is a true or false. If it's enabled, it's true or false, but description is a string. And we know how to start modeling our requests, and we can dig more into it. Along those lines, we also have the Pyang bind tool. And what this does is it helps us convert the Yang models into Python, which can be handy for us exploring the data. So what we can do is I'm just grabbing the setup string from their site. And what this does is basically create a variable called py bind plugin, and it tells it where to point to find that plugin. So to save some time, I just pasted this in. What we have here is we're running the pyang command, and we're calling that plugin we just set up in the variable. And we're telling it that it's going to be a py bind. We're outporting all these Yang files as this Python file, which we can import as a module. So if I hit enter, we now have a Python file that expresses all these Yangs there. And the beauty of this is we can work with this inside Python. So for example, I could say import Openconfig example. And then I can start consuming the models inside my code. So I took that and put that into what's called types. I now have a variable with the types of interfaces. You don't need to get too much into this for just the basics, but it's good to know that you can do stuff like this. So the last thing I want to do today is show you a quick little Python script I threw together. And what this does is it uses netconf to connect to the router to do some configuration. And it is also using Jenga 2 in order to dynamically create some configuration. So what I've done here is we're connecting to the router. That's probably not too surprising. And then I am pushing this XML configuration. The difference here is that I am using Jenga to push various variables into that configuration. So if we scroll down here, we can see that I am taking this configuration, running it through the Jenga template, and I'm dynamically saying that it's going to be interface 4. I'm adding the description, I'm adding this IP address and the subnet mask, and then that is going to be pushed. I do have a simple logic here, so if I right now commit is set to false, so therefore after 30 seconds it is going to roll back. And if I set this to true, then the configuration will be permanent. Now we're ready to run this. Before I do, I just want to show you. I'm going to show you a trick. I'm going to go archive, log config, logging enabled, and notify syslog. And now every command that's pushed to the router is going to be showing up in logging. So now if I run this, I'm going to go run, and we see we have 30 seconds. So I'm going to go back over here, and we can see that it has went ahead and pushed the configuration for the host name and the gigabit for the IP address in the description. So after about 30 seconds, what we should see is the router automatically negate these commands for us. And what we have here is we can see that the configuration is being undone. We see the no IP address, the no description, and the host name. So if I look at the interface, it should be good to go. That's been a fairly comprehensive look at netconf. Next time we'll probably have a look at its brother-in-arms restconf, which is basically the same thing but through HTTPS, which means we get to use our Postman tool again. I'll see you next time.